I'm waiting for that chime to kick in. There we are. Okay. All righty. Letter I. All right. Determine the coordinates of any points on the graph. Of any points on the graph of g of x, where the line tangent to g is horizontal. So you guys, what they are telling you is they need g prime of x to be equal to 0. Okay. Well, we've talked about this before. G prime of x in this context is just f of x. Okay. So that just means f of x has to be 0. So not a big deal. We just need to find out where f of x is 0. In other words, where does f of x have a 0? Where does it hit the x-axis? And so f of x hits the x-axis at -2 and 4. Okay, so we know that when x equals -2 and x equals 4, we're going to have a horizontal tangent line. Okay, all right, I need to reread the question. It says determine the coordinates of these points, okay, on the graph of G. So the problem here is I need the coordinates are going to be these coordinates. These are not intervals now. These are coordinates. The coordinates are going to be at -2, comma, g of -2. That's one of the points. And the other one is going to be at 4, comma, g of 4. All right. Now, on your AP Calc test, if you write this, you would not get full credit for that because a competent algebra student would not be able to do this. Okay. That requires concepts of calculus. So you need to carry it through a little further. Okay. So let's see about this g of -2. Okay. I haven't evaluated g of -2 yet. So I need to look at that and figure out what g of -2 is. All right. So let's take a look. Look at this. I'm gonna make room over here to do this. G of -2, I wanted g of -2 would equal the integral from -2 to -2 of f of t dt. Okay, I'm sorry to put the work here. I can't have this graph and the other problem. This is for part I. Okay, this is work for part I. I can't do that. Notice that this doesn't move. Right? X is not changing at all. And so that is by definition 0. That has to table 5.3 in your book. If the upper and lower bounds of integration are the same, that equals 0. So that means that the first point is at -2, 0. That's a point. Okay. I'm just clarifying that for you guys. The first point is at -2, 0. That's a point, not an interval. Okay. All right. The next issue is I have to calculate g of 4. Okay. So let me go back up here where we can look at the graph. And this is also for part I. All right, g of 4 is the integral from, just copying this down, from -2 to 4 of f of t dt. Okay, so I need to integrate from -2 to 4. Okay, from there to there, I need that area. Well, what's handy about that is that's just the area of this overall triangle here. Okay, and so that would be 1/2 of the base, 1, 2, 3, 4, 5, 6, times the height, 1, 2, like so, and that equals 6. Okay, so there I have it. That equals 6. And so I'm going to transfer that answer down here now. So we just worked that out. That would be the point 4, comma 6, and that's also a point. Okay, so those are my points. And you guys, you wouldn't need to write point on them on your test because it asks for coordinates. So if you answer, they assume those are coordinates. But I'm teaching you, and I don't want you to get confused that those are intervals. Okay. All right, next one. Determine the coordinates of any points on the graph of g of x, which they didn't give us, where there's a point of inflection, and justify your response. So here's what we need. We need g double prime of x to change sign. Okay, that's what we need. We need g double prime of x to change sign. That's critical. That's what has to happen. The second derivative of g has to change sign. So let's start off with what we know. We know g prime of x has to equal f of x. Okay, this is the fundamental theorem of calculus, basically saying if you integrate f and then take the derivative, you end up with the original function f of x. So we know that that's true. G prime of x has to equal f of x. So g double prime of x must by definition equal f prime of x. So what we're looking for is where does f prime of x change sign? That's what we need to find. The second derivative of g is f prime of x. Where does f prime of x change its sign? Okay, so we're going to look at this function f, and where does its derivative change sign? Well, its derivative is negative here, then its derivative is positive, and then its derivative is negative. So if I make a sign diagram of g double prime of x, which is f prime of x, I'm going to end up with it changing sign at -2 and 2. Okay? This is a negative derivative. This is a positive derivative. This is a negative derivative of f. Okay? So it goes negative, positive, negative. Okay? And so the second derivative is changing its sign here at -2. Now, the first derivative is actually undefined at -2. The first derivative of f is actually undefined. We have a corner here. But that doesn't harm my answer. What we're looking for is the concavity changes sign. So we have the point -2, g of -2. This problem asked for coordinates. So there's one possible one place. And then the other place is the point 2, comma, g of 2, like so. Those are my 2 points. Okay. So let's take a look at that. 2 comma -2 comma g of -2. Well, fortunately for us, just a few minutes ago, we worked out g of -2 and it was 0. So this point here is -2 comma 0. So again, that is a point of inflection, okay, which is interesting. It has a horizontal tangent there, and it's also a point of inflection. That's pretty cool. Okay, and then we need g of 2. So let's take a look at that. G of 2, I think we evaluated that way back in part A, didn't we? Yeah, there it is. G of 2 is 4. So we save ourselves some time. It's just 2 comma 4, like so. Okay, and there's our answers. Okay, and those are points. Those are the coordinates of points. There we have it. Okay. All right, and then finally, K asks us for all of the extreme values of G. Answer using specific coordinates for all points, include local and global maxima and minima, okay? So we need to think about this. First of all, the endpoints of this thing are on a closed interval from -5 to 5. So the very first thing you need to do in your work is you need to justify that you're looking at the endpoints, okay? You have to justify that. We have the endpoints at -5 and 5. That's the first step, okay? And let's talk about those. We're doing G. We're doing the graph of G. So let's look at the derivative at -5. At -5, f is positive. Remember, f is the derivative of G, okay? So that means that the function is increasing at its left coordinate, at the coordinate on the left. The function is increasing there. We're at the left coordinate. The function is increasing, right? Here we are. We're at -5, right? Function g, not function f, but function g there is increasing. So that point is the lowest point in the immediate neighborhood, okay? So that's a relative min, all right? This one has to be a relative min, like so. All right, whoops, sorry, I'm not writing on the paper. That's -5 has to be a relative min. Okay, let's talk about what happens at 5, okay? At 5, the derivative of g is negative, okay? So when we get to 5, the derivative there is negative. So that is also a relative minimum, right? That's the lowest point on this section. When we get to the right edge, the derivative was negative there. So that's also a relative min. Okay. All right. So where else do we need to look at? We need to consider where g prime of x, the derivative equals 0. And we've already talked about that. That's just f of x. So where does f of x equal 0? So we look back at this original graph of f, and we have to concern ourselves with this graph of f being 0 at -2 and 4. So there's a couple of other places to look at, -2 and 4, like so. Okay. All right. So we've got those on there. Okay. And then the next place we need to consider is where does g prime of x not exist? Okay. Well, g prime of x, that would be the same thing as saying f of x does not exist. Same thing. Okay. Well, let's look at the graph. There's the graph of it. F of x exists everywhere between -5 and 5. It's a fully defined function. Okay. So this is not something that we have to worry about. F is defined on the interval from -5 to 5. So we have done our search for critical points. Okay. Now we just have to decide what to do there. Okay. So let's consider it -2. At -2, the second derivative is undefined. Whoops, right here. At -2, that second derivative is undefined. So we don't have a good idea of knowing if that's a min or a max there, right? We can't use, we know we have a horizontal tangent here on G, but we can't use the second derivative test to figure this out for us, okay? Same problem with, actually with 4, that's not an issue. Let's take a look at 4. The second derivative that we did here at 4 is negative, okay? So we know the second derivative when you're at 4, the slope of this is negative. So we have a horizontal tangent here with negative concavity. That has to be a relative max, right? We know the derivative is 0 there, but the concavity is negative. So that has to be a relative max. Okay, and this puts us in a jam here of what we're going to say about this value at -2. So let's talk about that. Let's look at this. The derivative of g is just the graph of f. Okay, so if I just look at g prime of x and I make a sign diagram of it at -2. It equals 0, and at 4, it equals 0. So if I go to the left of -2, that value of that function is a positive value, okay? So g prime of x is f of x. So if I just make a sign diagram of f of x here, that's what this is. From -2 to -5, this is a positive number. From -2 to 4, that function f is a positive number. From 4 to 5, that is negative. And so the derivative there at -2 is momentarily 0. So we have the graph increasing and then 0 and then increasing again. So that is a point of inflection. Sorry, that's a point of inflection there, okay? And so now we just need to figure things out. We need to calculate it wants coordinates for everything, okay? So we need to calculate what's g of -5, okay? So I'm looking over my old work here for g of -5, and we don't have that on here, okay? So we're going to work that out. What is g of -5? Well, by definition, that is equal to the integral from -2 to -5 of f of t dt, okay? And gosh, I feel like we already worked that out. Didn't we already work that out? Look at that. You guys, we already worked that out. G of -5 equals -6. We've already worked that out. So this is -6. So we already have that there, okay? All right, the next one is we need g of -2. Okay, and fortunately for us, we worked out g of -2, and we calculated that was 0. So there we have that. Okay, then we need g of 4, and have we worked out g of 4 on here? Let's see. I'm looking over the work here. At g of 4, sure enough, there we have it. G of 4 was 6, like so. And then G of 5, let's see if we have that. G of 5, sure enough, we worked out G of 5 here. It's 5 1/2 or 11 halves. Okay. So fortunately for us, since f is defined everywhere, the integral g is going to be defined everywhere. And so now we simply have to decide of these points here, which is the absolute maximum value right there, 6. So this is our biggest value. This is our relative max, and absolute max happens at 4. And then our absolute minimum is here at -6. This is a relative min and an absolute min. Okay, and so there I have it, you guys. I've got my coordinates there. I'm running out of paper here since it asked for coordinates of everything. I guess I'll just write them all down for you. So -5, -6 is both a relative and an absolute min. These are points. Okay, then I have -2, 0 is a point of inflection. Okay, then I have 4, 6. That's a relative and an absolute max. And then I have 5, 5 1/2, which is just a relative min. And there I have it, you guys. Okay, that is hard work. Okay, I would much rather have done this with you in class. Okay, those are hard. All right, but we got through it. And we're doing well, you guys. All righty. You may need to watch this video a couple times for it to sink in. It was tough. It took me a few tries to get it right. Okay. All righty, guys. All right. Take care. Bye-bye.